Welcome back, everyone, and we are right there. Um, if you have actually gone over my free introduction to PLC course, you you know some of the stuff we're going to be talking right here. But if not, it's probably a good idea to review that free course on controllers. That's my free course for you, Introduction to PLCs. You may want to go and review this course before you dig into the next lessons. If you haven't done it, I encourage you to highly join this class. I know many of you have taken this class and have enjoyed it, but I will say if you're new to the ladder logic programming, you want to review this as a basis for what we're doing. So anyhow, let's go over some of the steps that you need to keep in mind as you design ladder logic programs. All right, for PLCs. In a nutshell, there's actually not a rule that you have to follow, but these are recommended steps that they usually work well for you to know how to tackle a design problem in industrial controls using ladder logic PLCs. So step number one, you want to define the problem, what problem you need to solve. Step number two, you want to identify the output elements you want to control. Step number three, you're going to identify the input elements that you will use to control those output elements, right? Step number four, you're going to create the rungs on ladder and identify the components associated with the rung. On step number five, you're going to go ahead and test the program for errors. If there's errors, you're going to debug the program if needed. And then seven, you're going to optimize. How can you better create and do that project? So those are the basic steps that you do need. So here's an example. I'm going to dig into the actual program in here, but let me just give you an example. So here I have defined a problem. The problem is to control a room AC unit. So how we're going to control that AC unit on that room. And then that will be step number one. And then step number two and three, define what kind of IOs are needed. And I have listed the IOs in here. We're going to need a start device. We're going to need a temperature switch. We're going to need a manual control. And then we're going to need the AC unit and fan. So it looks like we got 3 inputs and 1 output, or 2 outputs. All right, so we have gone through steps 1, 2, and 3. The next step will be to actually create the rungs and identify the components. So, and then you're going to test, debug, and optimize. So without further ado, I will just close this out and bring back my ladder logic programming software, which again, if you have done or taken my introduction to PLC, you will be familiar with the software. Otherwise, you're going to learn it as we go here. All right, so I'm going to start a new program, and I'm using a real software, but limited version. This one is only what they call a RS Logic Micro Starter Lite. It's a limited version of the actual software that is used for controllers. As a matter of fact, all the 1100 series of Allen Bradley controllers can be controlled with this software. Or you could actually use the Emulate, which is a software that allows you to program on your computer and test and debug without having an actual piece of hardware. I actually have both the simulation software, and I also have the hardware. And we'll give further instructions on how to go about this as we dig into the next lesson. But just as an overview here, I'm going to select the MacroLogix 1000 controller. And here I will select, if I can, I have a little trouble. I'm going to keep that driver. It might be necessary for me to change. We'll see if we can do this. So let's go ahead and start. And you're looking at the programming screen of ladder logic. Again, I have given you lessons on how to get familiar with the basic tool set or instruction commands in here. So if we go back to our screen, this one right here, it looks like we got a start device, a temperature switch, and a manual. That's 3 inputs, right? And also we're going to have the AC unit and the fan, which could be a compact unit. The AC will have the fan. So it's basically one single output for that matter. So we're in step number 4, actually creating our ladder logic. And so let's see the logic behind that. We actually did not provide you a full description, but we're going to make the assumption. So first of all, let's go ahead and start. We're going to introduce a rung. We actually will need at least 2 rungs. So I'm gonna create 2 rungs in here. All right, I will need 1 output, and it looks like I have 3 inputs, right? 3 inputs. All right. So let's define here how it is that this AC unit will be controlled with this controller here via a ladder logic program. So first of all, we want to be able to identify those elements, all right? And it looks like the conditions will be, if we go back here, all right, so we can write operation. That will be more of a description, right? The operation of this system consists of, all right, we're going to say that start and temperature switch will turn unit on, right? Or manual control will turn unit on. So we got 2 conditions, right? It looks like we got in the first place the start and the temperature switch being an and that or with the manual control. So that is actually the basic operation of our system. So I'm going to go back here, and if that's the case, it looks like I will need a branch. I'm going to create a branch right here. Notice that I can click on the component, I can hold it down and drag it over, and when I see the green X, I release it. I do the same with this one. Hold it down, bring it over. When I see the X, I release it. And this one is going to come down here. Why is that? Well, because I'm actually setting up the architecture for this thing to work. I'm gonna just put a little looser right here. All right. This is not in the description. I'm just gonna add it. I'm gonna throw there a couple of items which are kind of luxurious items. You don't need them. I'm gonna put them in there. So now we have the basic relay ladder logic schematic for this thing. But I need to come up with what we call the addresses or the right labels for this thing to work. And the way we do labels here, you can do manual by double clicking on the question mark and do an I for input. Oops, not taking it. It's not taking it. So I was going to do addressing of these components, but let's just do, I'm going to pull out my input table here. You see that? And with my input table, I'm going to start using these addresses that are already here on the data file. So I'm going to click on address 0, hold it down and bring it over on top of that first element. I'm going to use a second address, hold it down and bring it over, release it, and I'll use the third address, which is labeled bring it down and release. Okay, and I'm going to use the output table here to label my output components. I'm going to use output 0 to address the AC unit. I'm going to use output 1 to address a pilot light. What about this guy right here? Well, if the system is on, okay, I'm going to make a little change here. So I'm going to change this to be a normally open, sorry, and remove that. And this is only a bit-based instruction. I want this system, when the system is turned on, I want a pilot light to be on. All right, I hope it's not too much for you. Let's review what we got. All right, here we got the start and the temperature switch. When the start is on and the temperature switch is on, the system will be turned on, right? Or when the manual button is on, the system will be on. Additionally, because I have an address 0 here and I have this input address with address 0, anytime this guy is on, this pilot light will be on, right? Energized by this one. So now what I need to do is I'm going to add labels to the thing. I'm going to right click. I'm going to put edit description. And I'm going to call this input 0. That's the start button. And this is, I just right click, input 1. That is going to be the temperature switch. Okay. Boy, this video is getting long, is it? But anyways, this is a good example. And this will be the AC unit. Okay, notice that this one automatically gets that label because this address is the same as that one, which means every time this is energized, I want this pilot light to be on. And I'm gonna call this manual switch. And finally, I'm gonna call this pilot light, pilot indicator. And so if I go back to my process of my 7-step, I have created the rungs and I have identified the components associated, right? Do you agree? Yep. I created the runs and I have identified the components. So this is an AC unit that's going to be controlled by a start button that has to be enabled, temperature switch that has to be on, and this unit is on, and this light indicator is on. Or I could have the manual switch turn the unit on, and again this will be on and that will be on. All right, now our next thing will be to verify, right? Next step will be to verify. Test the program for errors, and hopefully we don't have anything else to worry about it. So here I go, and notice that you don't see it, but right underneath it says verified, completed, no error found. You're gonna find that at some point. It's right under here. You see it right here? Verify has completed, no errors found. So we're good. We have tested our own thing here, and now we should be ready to run it. And let me see how my video is doing. That's 14 minutes. All right, so we can run this thing if we want to, so that we can see the functionality of it. Give me 1 second. I'm going to set it up so we can run it. Okay, so having done everything we did, we're going to go ahead and download this thing. I'm going to go to my program here. I'm going to say download so that I can download it to the controller. I'm going to say yes, place it in download. I want to go online. And one more time, I'm going to run it. Yes, run mode. So the system is in run mode. All right. And it looks like everything is working the way it's supposed to work. I'm going to enable this via software. I'm going to manually run this application. I'm going to toggle a bit here. And you can see that as I toggle or turn on the manual switch button, the system goes on. Not only that, this input is energized and the pilot indicator is also energized. So I'm going to untoggle this, bring it back to 0. I can also test the other two conditions. Let's just say that the system is in the start mode, right? And eventually the temperature switch closes this other sensor, and as it does that, it also puts the system to work. So there we have our first functional system. Our PLC program is working. There's no further work that needs to be done, but before I close, let's go back and review. So we defined the problem, we identified the input and output, all right? We created the rungs, we defined the operation as a middle step process. We test the program for errors, we debug it, and we optimize it, which we didn't need to do that. But anyways, here is our ladder logic, and we're all set. All right, this is the end of this part. Get ready to do massive ladder logic programming, okay? We've covered quite a bit on relay schematics, and we've introduced, closing that section with an introduction to PLC programming. I'm going to go back and give you more details on how you pull the software, how to put it together. Once again, if you haven't taken my free introduction to PLC class, you want to do that because it will be beneficial to dig into this one, right? Thank you very much. I will see you in our next class.